So we left off on this problem, and we had decided that there were two triangles determined from the information given, since the angle we were given was acute, and then the sine, we were finding alpha and its sine was less than 1, which tells us that there are two angles between 0 and 180 that have that sine, right? And we found the first one was 45.8 degrees, and then we subtract from 180 to get the other one. So if you put these in standard position, this one's in quadrant 1 and this one's in quadrant 2, and the first one would be the reference angle of the second one. That's why we subtract from 180. Okay, so now that we have all of that, we need to find the rest of the parts of the triangles. So I already wrote this down on this piece of paper here. We have our first angle that we found in our second. So now, both of these, of course, we were given beta is 26 degrees. And I'm just going to write these down quick. I should have wrote all this. This was all given information. All right, so the first three parts are all the same. The rest are going to be different. So now, for gamma, we'll just subtract from 180 the angle we were given and the one we found. And so I'm using the subscripts to differentiate between the two. I should use approximately here. Whoops. 134.2 degrees. Let me get my calculator out. Whoops. So 180 minus 26 minus 45.8. So in the first one, gamma is the obtuse angle. And then 180 minus 26 minus 134.2, 19.8 degrees. That's a smaller angle, of course. And now the last part to find is C. So these are going to be different lengths because they're across from different sized angles, right? In this problem, C is going to be a lot longer because gamma is so large. So we'll just use the law of sines to find C. So I would use these two because they're given in the problem. Then you're not using anything you rounded, although you could use these two as your ratio. But I like to use the ones given if I can. So we have the sine of 26 degrees over 11 equals the sine of 108.2 degrees over C1. And we rounded that, so we'll get a little round off error, but that's okay. And then sine of 26 degrees over 11 equals the sine of 19.8 degrees over C2. So these first ratios are the same, it's just the different gammas here across from the side C. Excuse me. All right, so cross multiply and divide. C1 equals, it's actually approximately equal to, but we'll use equals, sine of 108.2 degrees over sine of 26 degrees. And here, 11 sine 19.8 this up degrees over sine 26 degrees. So again, make sure you're in degree mode. I have to double check because it's been a little bit a while since I made the other video. You can tell by my voice. Just plug this in quick here. 23.8. We'll just, again, the numbers in the problem, we had one decimal, so that's what we will round to. And then 8.5. So you can see, like we said, this one is a lot larger because gamma 1 is a lot larger than gamma 2. So we'll circle those. So make sure we circle all of our answers. Right. There we go. So again, on this ambiguous case was when you have the acute angle and the side opposite the given angle is shorter than the other side you're given. If it's longer, then you're not going to have an issue, and we'll look at a problem like that as well. But it's shorter, and then you have to determine, does this reach the base or not? Like this one, this did not. This is actually too short to even be the height. And again, the sine value tells you that. If this is bigger than 1, no solution. If this equals 1, then you actually have a right triangle. Beta will be a right angle, since the sine of 90 degrees is 1. And then if that is less than 1, then you have potentially 2 solutions, although, well, you do have 2 solutions if this is acute. Let's say that. If that's obtuse, however, then there's only going to be 1 solution. And that's actually our next example here. So let's go ahead and do that one. So because that's obtuse, there's no way we can get 2 triangles. So gamma is 110 degrees. C is across from it is 240. B is 180. So I'm going to make this C is 240. B is 180. If C were to be shorter than B here, then there wouldn't be a triangle, of course, but it's longer. So we have a triangle. So we'd have sine of 110 degrees over 240 equals, so we have to look for beta first. That's the one side, our angle across from the side we're given. So sine beta over 180. So cross multiply and divide, we get 180. Whoops. Write down sine beta first, sorry. Sine beta equals 180 sine 110 degrees over 240. So sine beta equals 0.7047, etc. I want to write all those digits down. And so at this point you might think, well, then there's 2 angles that have this sine, and that is true. There would be an acute and an obtuse angle that have the same sine value, but it has to be the acute one only, because if you use the obtuse one, that's going to be too large to fit into the triangle. So this would imply beta equals the sine inverse of this number. And I'll just put that in my calculator. So that's approximately 44.8 degrees. And if you subtract that from 180, 135 degrees, that's way too large to fit in this triangle, right? So that's why there's not a second triangle. And again, if this is obtuse, then you don't even have to worry about this second case. Okay, so we have beta is approximately 44.8 degrees. Then alpha would be approximately 180 degrees minus 110 degrees minus 44.8 degrees, which is 25.2. Oh, I'm still round. Well, these are all in one place, so we could round to the nearest whole number, I should say, not one place, to the nearest whole. I'm still going to leave it as 1 decimal, though. And then what do we have left? A, right? Yep, so we need to find A. I'll do that over here. So sine of, so I'm going to use this ratio again because it was given, 110 degrees over 240 equals sine of, and A is across from alpha, whoops, need a degree sign there, 2 degrees over A. So I'm running out of room, but you cross multiply, divide. I'm just going to write down what A equals. So 240 sine 25.2 divided by sine 110, 108.7. And that's a side, so of course we don't need to label since there's no labels in the problem. There's our answer. And again, you know, think about biggest side, longest side, or biggest angle across from longest side, shortest side across from the smallest angle, and A is the shortest side and alpha is the smallest angle, so everything seems reasonable here. All right, let's look at D. So in D, we have beta is acute again. So especially when that happens, make sure you draw the triangle in a way that you can kind of figure out if you have the ambiguous case or not. A is 16.2 and B is across, so this is my side across. And but I want you to notice on, excuse me, on this one is because B is longer than A, there's no possible way for there to be 2 triangles. This is longer than this side, so if you swing this back so there's 2 angles, it would be out, you know, couldn't fall in here. And so there's only going to be 1 triangle in this case. Well, let's look at the mathematics. So sine of 72 degrees over 20.3, whoops, equals the sine of alpha over 16.2. So cross multiply, divide. Let's see what we get here. 16.2 sine 72 divided by 20.3. 0.7589, etc. So take the sine inverse. 49.4 degrees. So at this point you think, okay, there could maybe, if you hadn't drawn the picture, let's say that, and you didn't know that you've already realize that there could only be 1 triangle, and you're thinking, well, there could be 2 triangles here, so I should find the other angle, right? Because you don't know yet. So you go ahead and say, all right, well then that implies alpha 2 would be 180 degrees minus 49.4 degrees. And you get 130.6 degrees, approximate, well, that's fine. And so look, then you have to notice at this point that when you add that to the angle given, 72, that adds up to over 200 degrees. That's not possible. So the mathematics will support your, you know, what you see here in the picture, since beta plus alpha 2 is larger than 180 degrees. Oh, oops, sorry, that's not on the screen. So you toss that out. If you drew the picture correctly, you would notice that. You wouldn't even have to worry about this. But if you don't notice it here, you should still notice it here, but you have to be paying attention, of course. All right, so we only have 1 triangle. We have alpha 1 is approximately 49.4 degrees, and from there you should be able to finish the problem by now, but I'll just go through it really quickly. So gamma, and we don't even need the 1 here, there's only 1 triangle, so we'll just call it alpha. do that quick here. 58.6 degrees. And then we need to find C. So sine, we'll use 72 degrees over 20.3 again, equals sine 58.6 degrees over C. And then I'll just quick throw this in my calculator without writing anything else down. 18.2. There we go. Okay, I'm going to take a little break then before we finish the last part, which is, I think, area. Yep, area of a triangle. Okay, so we've covered all the cases. You can see there's quite a bit with that ambiguous case to think about, so make sure you study that.